Okay, now that we've had the time of our lives, we have to get down to the nitty-gritty details of our nervous system, endocrine system, and the stress response. So when we were dancing, our nervous system was acting, and our endocrine system was acting because dancing releases endorphins, which makes us happy. Right? Are you all happy? Okay, I need to catch my breath. I danced harder than I thought I would. Okay. So, now that we're all settled down, could everyone raise their hand if they think that their physical health is important? Yes, all of us. Great. You're in the right place. Because, okay, if we all agree that our physical health is important, then it makes sense that we understand a bit about how our bodies actually work, right? Right? Yeah. Right. Great. Okay, so let's face it, without our health, we have nothing. It doesn't matter how knowledgeable we are, it doesn't matter how much money we have, it doesn't matter how famous we are, how many people love us. Without our physical health, that's it. Kaput, nothing. Okay, it all becomes meaningless, and what are we all doing it for, right? Because then you can't even enjoy the fruits of your labor. So it makes sense to pay respects to the thing that literally allows us to live, right? Yes. Right. Okay, so that, first of all, we usually take our health for granted until it's gone, right? When it's gone, then we start caring. Because we take it for granted the whole time. But why wait until that point? It just doesn't make any sense. Does it make sense? No, it doesn't. Okay? So that's why today we are going to become aware of and understand a bit about the two major systems that began our multicellular organism evolution, the nervous system and endocrine system. Okay? Okay. These two systems basically govern everything else in our body and make sure everything is working smoothly. But the difference between these systems is the nervous system communicates through electrical charge called neurons, whereas the endocrine system communicates through chemical messengers called hormones. So let's start with the nervous system. There are two main branches of the nervous system. The central nervous system, which is basically the brain, and the spinal cord, which both are bathed in cerebrospinal fluid. The central nervous system is basically our main information processor and integration center. So all of the information that our sensory nerves gather from our environment is fed back to our central nervous system, processed, and then it enacts some kind of response, a physiological response. So on the other hand, there's the peripheral nervous system, which is basically all the nerves and ganglia in our bodies that run through everywhere in our body, like electrical cables that transmit signals, okay? And feeds back signals to our central nervous system. Within the peripheral nervous system, there are two divisions. There's the motor and the sensory division. Okay, so there's the somatic nervous system, which is basically our voluntary skeletal movement. So when you guys were dancing, that was the somatic nervous system. And when you put your hand up, again, somatic nervous system. And when you walk and run and so on. However, there's also something called a somatic reflex arc, which is something that is like a sensory nerve or an afferent nerve, passes through whatever stimulus, like your skin, feeds back to your spine, and it completely bypasses your brain, and then your spine sends out a motor neuron to then have a muscular reaction. So that's when, like, you accidentally touch a hot stove, and then you instinctively remove your hand. So you didn't have to think, oh shit, it's hot, I should move my hand. You move your hand, okay? So that's the somatic division. So the next is the autonomic nervous system. Basically, this governs pretty much everything from your heart beating and breathing, your digestion working, your immune system working, your circulation, everything. You're not having to sit there and go, I should breathe right now, or else I'll die. No, your body knows, I need to breathe, okay? So very, very important autonomic nervous system. Within that, there are two branches. You've probably heard of them: sympathetic nervous system and the parasympathetic nervous system. So the sympathetic basically conserves your energy in order to utilize it in a fight or flight response, okay, which is your body's response to stress, versus the parasympathetic basically is in charge of your rest and digest state. So once your fight or flight response goes up, your parasympathetic puts you in the rest and digest state to further conserve the energy so that it doesn't get all wasted. Okay, so is that too fast? Am I speaking too fast? Okay, great. Okay. So, okay, I'll go into the parts of the brain because that's part of the central nervous system. It's very important. You must have heard of the brain, right? So the frontal lobe is for your cognitive higher functioning, so thinking, speaking, reasoning, problem solving. Then behind that is the parietal lobe, which is your sensory lobe, and it's in charge of your body orientation and your language. Then behind that is the occipital lobe, which is in charge of your vision. Then right below that, at the back, is the cerebellum, which is your coordination, your balance. And then at the bottom is the brainstem, which is connected to your spinal cord, and it's in charge of breathing and heart rate and temperature. Then on the side is the temporal lobe, which is to do with your auditory ability, but within that is the limbic system, which is comprised of your hypothalamus, thalamus, amygdala, hippocampus, which is kind of like your emotional processing center for memories and behavior. And people also call the limbic system the reptilian brain, or like the second brain, because it's like your reflexive reactions to things, and it's also your emotions. So obviously a lot of us, sometimes we don't think logically. So we think with our emotional response first. And so that's why people call it the second brain. Okay, so sorry, back to the sympathetic nervous system. So basically, the sympathetic nervous system is your stress response. So when you encounter a stressful stimuli, or you perceive something to be stressful, it might not even be a stressful thing, but you have perceived it that way, then the body stimulates and mobilizes your energy and pumps adrenaline into your bloodstream. So that would increase your heart rate and dilate your lungs, and it lowers your gastrointestinal motility and secretion. It loosens your bladder, it increases metabolism, and you have more sweat and less saliva. So in order for it to actually do this and to mobilize all the energy so that your body can then respond, like if there's a dangerous stimuli there, your body thinks you're being threatened, your safety is being threatened, then you have to have a burst of energy in order to get away or fight or flight, right? In order for it to do this, it needs to take energy from other areas of your body. Okay, so that's why it has to shut down your digestion, because your digestion uses energy all the time, and it shuts down your immune system, which is always adaptive immunity. It always is working, which requires ATP energy, and for example, your reproductive cycle also. So all those things shut down, which in the moment, as an acute response, is fine in order for you to get away from the threat. However, if the sympathetic nervous system is activated for a long period of time when it's not supposed to be, then all of the organs that need energy and that usually use energy have no energy, okay? Because your body is too busy being stressed. So then your digestion, your immune system, your reproduction, it all becomes dysfunctional because there's no adequate energy going to those places. Okay, then that's when your body just goes out of whack, and then you go into disease. So overactive sympathetic would cause anxiety, panic attacks, nervousness, insomnia, palpitations, poor digestion, high blood pressure, high cholesterol, and so on. So yeah, here's a diagram of the fight or flight response. Basically, your hearing shuts off. You get tunnel vision, you breathe faster, your heart starts to beat faster, so you've got a pounding heart, and your digestion slows. You get tense, and your bladder relaxes, which is why you feel like you need to go to the bathroom when you are afraid. Okay, so on the other hand, as I said, parasympathetic nervous system is what happens when your body goes into a relaxed state, okay? So if your sympathetic nervous system is just leaking energy, you're just constantly producing adrenaline, and then all your organs are not getting energy, then your parasympathetic has to usually kick in, okay? But usually when people have chronic stress, that sensitivity of the systems is, it loses sensitivity basically. So your sympathetic is abnormally stimulated, so then your parasympathetic nervous system tries to overcompensate because there's too much stress hormones going on. Because it's trying to overcompensate, it tires itself out. The parasympathetic becomes worn down from constant suppression, and then eventually the ability for you to relax just degenerates. So you just, physically you can't even relax. It's harder and harder for your body to go back in your rest and digest state. So then your sympathetic has no regulator. Your sympathetic nervous activity is just through the roof because your parasympathetic activity is so dysfunctional. By the way, in parasympathetic, your heart rate is lowered and your digestion and secretion increases, your bladder becomes stronger and your metabolism lowers, your pupils constrict. So basically, you calm down. So what I want to do is I want you guys to watch two different videos, and I want you to notice how you feel and the difference of how you feel between both of them, okay? Okay. Okay. Okay, got that? Who's crying? I'm crying too. So, how did you guys feel watching the second video versus the first video? Yeah, so which one's the sympathetic? The first one, yeah. And the second is the parasympathetic. Yes, and this horse is actually calming down the patient's sympathetic nervous system as well, and brings them back into the parasympathetic, where they can actually relax enough to feel their emotions and feel their heart. And it also brought you guys into a parasympathetic state as well, because we were all like jittery from dancing, and then now we're all calm, we feel relaxed, our heart rate slows, our breathing deepens, we are feeling tears, feeling, how do you feel? Peace, joy, gratitude, all those things, yes. Okay. So, okay. I just want to touch on the vagus nerve. This is the 10th cranial nerve. It is the main parasympathetic nerve in the body, but this nerve can actually get, the connection of this nerve can actually be shut off when you have chronic stress, and then because that nerve has shut off, the parasympathetic nervous system function actually becomes impaired. Okay. So, okay. So in a fight or flight response, right, we perceive a stressful event, so our amygdala, the part in our brain that is responsible for emotional processing and reactions, fast reactions, sends a distress signal to the hypothalamus to then activate the sympathetic nervous system to pump adrenaline into the bloodstream for a boost of energy, right? You know that. So this is kind of, this connection of the hypothalamus and the pituitary gland and the adrenal gland is called the HPA axis. So the HPA axis is in charge of the sympathetic and the parasympathetic nervous system for the hormones to travel rapidly between these organs. So then after the fight or flight, your parasympathetic usually would kick on, right? However, if your brain continues to perceive that there's a threat or that there's danger or some kind of stress, then your parasympathetic does not get stimulated, and instead your hypothalamus secretes corticotropin-releasing hormone, which then secretes adrenocorticotropic hormone from the pituitary gland, which then goes to the adrenal glands to secrete cortisol, which is the main stress hormone. Okay, so cortisol has a negative feedback loop with the hypothalamus. So usually once cortisol is secreted, then it sends a signal back to the hypothalamus telling it to shut off production of corticotropin-releasing hormone, so it doesn't continue producing cortisol. However, if there's a continued stress response, then that negative feedback loop can eventually start to degenerate, and then once you actually secrete cortisol, then because there's no negative feedback loop, your hypothalamus continues to secrete corticotropin-releasing hormone, which then continues to secrete cortisol. So that's when you're stuck in a loop, okay, and that's when things like autoimmune disease would arise.
Imagine you're getting ready to race. The stress you feel makes your brain signal the adrenal gland to produce epinephrine, or adrenaline. Adrenaline increases your heart rate. As a result, more oxygen gets to your muscles. That makes your body ready to react. In a longer-term response to stress, the glands secrete cortisol. Cortisol promotes the release of energy, making you ready to race.
Yes, so as you know, stress actually affects all areas of our health, and you know why? Because stress physiologically creates inflammation, which is the body's response to purge toxins out of the surface, okay? But as a result, inflammation, when it's not acute response, when it's not an acute response of inflammation, instead it's chronic inflammation, that is actually the major cause of all disease, and people don't actually usually know that. And so when you have chronic inflammation, that means your body can no longer heal itself, like your cells are not mobilizing to even heal itself, repair, or regenerate its own cells. So then what happens when you can't repair your cells? Then your cells die or they become diseased, and your body starts to attack itself. You can even bring this on not even physically, but mentally or emotionally. If you are fighting against yourself mentally or emotionally, right? It's like you are trying to be in denial and you're trying to repress your feelings and you're trying to disown yourself and you're constantly fighting, then your cells are also constantly fighting. When your cells fight themselves, that's the literal definition of autoimmune disease. That's when your cells can no longer differentiate your own cells versus invading pathogenic cells. So you just start to break down physically. And so, yeah, stress affects your digestive system. So people would get ulcerative colitis or irritable bowel syndrome when they have chronic stress, or they'd get high blood pressure or chronic pain in their joints like arthritis. And even like hormonal problems, menstrual problems, infertility, chronic fatigue, thyroid disorder, diabetes, hyperglycemia, depression, anxiety, insomnia, you name it, okay? So you'll find that stress, chronic stress, and emotional stress that you've brought on yourself is the actual main cause of a lot of these things because it causes inflammation. Okay, so I know I repeated a lot of stuff about that, but I did want to reinforce things. Did you all get that? Yeah, great. Okay, so I want to move on and I want to talk about what actually makes up a nerve, okay? Because your nervous system is made up of nerves, and your nerves are made up of nerve cells, which are neurons. So this is the anatomy of a neuron, briefly, okay? So you've got the cell body, which basically integrates and processes information and protects the cell. On the end are called dendrites, which they are like little branches that receive signals from other neurons, okay? And obviously within is the nucleus, the brain of the cell. Then this long part is the axon, which transmits the signal to another neuron, but the axon is surrounded by a myelin sheath, which is made up of lipids and proteins, which basically protects the axon from degradation and also ensures that there's like a rapid transmission going on. And then at the end is the axon terminals, which house vesicles that have neurotransmitters. So these axon terminals transmit a signal to another nerve to then transmit a signal to another nerve, and so on and so forth. But the way for these neurotransmitters in the axon terminals to be secreted into the synapse, you need to have an action potential. Okay, so sorry, here's like an actual diagram of that. So here are the vesicles in the axon terminals. They hold the neurotransmitters. When an action potential fires to fire a certain cell, the neurotransmitters are released into the synaptic cleft, which is the space between two neurons. Then they bind to the receptors on the dendrite of another cell. Okay? Make sense? Cool. Okay, I'm going to quickly go over membrane and action potential. Okay, I'm going to like simplify it though. Okay, so in order for us to have thoughts or actions or senses, our neurons have to fire, okay? When they're not firing, that neuron is at resting potential. So that means the inside of the cell is negatively charged and the outside of the cell is positively charged. The resting potential is minus 70 millivolts. So for an action potential to fire, the cell charge has to go to 0, okay? So yeah, when the neuron is at rest, basically the way it maintains being at rest is through a sodium-potassium pump in which 3 sodium ions are being transported out of the cell and 2 potassium ions are being transported into the cell. And because there are more cells leaving, more ions leaving the cell than entering the cell, that makes sure the inside of the cell is negatively charged, okay? So when neurotransmitters bind to the receptors of another cell or another neuron, they have a depolarizing effect on the neuron, so it starts moving towards 0 millivolts. So it has to basically reach this minus 55 millivolts, and that's the threshold. So when the threshold is reached, the sodium channels open, sodium ions can go into the cell. That makes the cell positively charged. With the influx of positive neurons, the electrical signal or the action potential fires. That's when your neurotransmitter is being released, and the signal is going down the axon, and it's going to the next neuron, and so on and so forth, okay? Once that fires and the action potential reaches its peak, then the sodium channels close and potassium channels open, so the potassium flows out of the cell, and it causes the neuron to repolarize, so your action potential falls, okay? Then it falls to below the resting potential, so it goes into hyperpolarization, which is like a refractory period. Refractory period means that the same neuron can't fire immediately again, okay? It has to repolarize. So here's a quick video. So these are the sodium ions repolarizing the cell. Sorry, these are the sodium ions repolarizing the cell. So that's an axon terminal with the vesicles holding the neurotransmitters in them, sending them into the synaptic cleft where they are being taken in through ion channels. This is not exactly accurate, but this is like just a visual representation. I wanted to show you how cool it looks, okay? Because it's pretty cool. Like, what is this? It's pretty insane when you actually watch it. It's like, really, that's happening like at all times with less than milliseconds. It's happening with everything you do, with you breathing, blinking. You know, every single thing you do is happening because of your nerves firing, okay? And we don't even know it. It's crazy. That's why we're learning about it. Okay, so you know about synaptic connections. So basically, there's this thing called neuroplasticity, which is the ability of the brain to form and reorganize synaptic connections. And it usually is in response to learning. So frequently used synapses, so when those nerves are firing and then it goes into that refractory period, if you keep thinking the same thought, or you keep doing the same action, and that synaptic connection continues to fire in the same way, then that refractory period gets shorter, so that those neurons actually fire quicker the more you do it. So that's why synaptic connections, the more you use them, the stronger they get, the faster they fire. And then the synaptic connections that are barely used, they start to, eliminate themselves, okay? They get weaker, then they eliminate themselves. So when you have a strong synaptic connection, that's usually because you have a habit, some kind of pattern that you do every day, you think every day, you feel every day, or some kind of behavior that you do every day. So there's established thought patterns. So the more you do them, the longer you do them, it becomes harder and harder to break it. It becomes harder to de-strengthen those synaptic connections. But it's not impossible, okay? So people say that, I can't learn anything new, I'm too old. Or I can't change, he can't change, he's too old, I can't change his habits. Or I'm too far gone, I can't change my habits. It's not true. Like, just because when you're young, your brain easily creates new synaptic connections because your brain is still developing, doesn't mean that it's all over for you once you get older, okay? So, pretty much, each time we feel the same emotion, okay, we choose the same thought, we choose the same emotion, we trigger the same neurons, and then we trigger the same hormones to then release, and we trigger how we feel, okay? It creates how we feel. Hormones create how we physically feel in our body, then that may create our actions, which then creates our state of being, right? But what happens if you choose a different thought that chooses a different synaptic connection to fire, and then that triggers another hormone to release or not release? And then that triggers you feeling differently in your body because that hormone did or did not release. And then you have a different feeling, so you act differently, and you treat others differently, and you see the world differently, and then your state of being eventually changes. So it's possible by conscious decision, okay? Your consciousness is actually what governs your brain. Your consciousness, I guess, on the physical level, your consciousness is your brain, but if you are your thoughts, on a physical level, if you are your thoughts, and your thoughts are just neurons firing, and then your neurons trigger the hormones and triggers how you feel, triggers your physical health, triggers your state of being, then technically that means you can control everything, okay? It means you can control your state of being. You can decide how you feel, and you can decide if you are healthy or not, okay? It's a matter of choice, and it's a matter of consciousness, and it's a matter of awareness, and making that conscious choice every morning when you wake up, choosing to, no, I'm not going to react to this asshole. Okay, like I always do, I'm going to react. My synapse is so strong. I could just really easily, call them a bad name, but I won't. I'm going to use the techniques that Hong and Mike taught me, and I'm not going to react, and I'm going to keep my dignity. Okay, I'm going to choose another path. I'm going to choose the road less traveled. My synapses won't like it because they'll have to make more effort, but that's the way it goes. So you make new synaptic connections and you keep making that different choice. You keep feeling that different way. You keep acting in a better way. Then eventually those synaptic connections get stronger. And then once they actually become stronger and then your previous pattern gets, weaker, then that's not your habit anymore. Now you're in your state of being, and your first response to being triggered is not, I'm going to kick him in the balls. It's, I love you, I accept you, I understand, I'm not going to curse you because I love your soul for who you are. Okay, and this is not you. Okay, I understand that this is not you, and I'm not going to take it personally. I'm not going to let it affect how I feel. Okay, I'm not going to let this asshole trigger me. That's power. Okay, you feel powerful, right? It's powerful because you're taking responsibility for how you feel. You're taking responsibility for your health, how you feel, your life, and you're taking responsibility for your reality, okay? You can't blame anyone then. You can't go, oh, he made me feel this way, so I had to act that way. He was asking for it. Like, it's easy to think like that. And, that's probably, your synapses are super strong there, but, it's actually real power when you can own every single thing in your life. You can own your physical health, and no one can take that power away from you, okay? That is your God-given right. It is what gives you self-respect. It is what gives you dignity. It is what gives you self-worth. And it is what helps you cultivate self-love, okay? And no one can take those things away from you because then that becomes your state of being, okay? Does that make sense? Yes.